Hello everyone to another episode here on the Subscribe blog, and based on discussions I had on Twitter and discussions I saw coming by on Twitter. Today I'm going to talk about coupling in a few dimensions, and specifically coupling around messaging systems or distributed systems in general. And when I talk about coupling, I mean there are two or more components of a distributed systems, or pieces that are interacting, A and B, where A takes a dependency on B by asking it a question or sending it a message. A and B, without that line, live their happy, parallel, independent lives and don't care about each other. As soon as you start drawing that line, as soon as you make a connection, they do. A will now be dependent on, first of all, the availability of B. If B is not available, A will no longer function. At least it will not allow that particular activity that you're trying to do to succeed, because if B is available, A will fail, which is very unfortunate. Also, if you have hundred-thousands of A's, you now will also make the A's dependent on the scalability of B. If B can only handle 1,000 concurrent A's, and you are in the unfortunate position to be number 1001, then you will not get any service. So while B might be available, it might just be overstressed. Also, if it is overstressed, A might also be dependent on getting timely service. A's timeliness, A's ability to go and give answers in a timely manner depends on B also being able to perform. So A takes a number of dependencies on B, and that is coupling. We're going to get to data extensively a little later, but let's talk about those dimensions of coupling first. So A is now coupled to B in all of those dimensions. Let's go and try to tease some of those apart. So availability first. What can we do if B decides to go away? Now A is no longer functional. We can go and abstract B by putting something in the middle and telling A, hey, you're not going to talk to this guy anymore directly. Instead, you're going to talk to this guy. That guy is an abstraction, and we're going to call this thing a load balancer, which also handles failover. And so now we're going to go and set up multiple B's. And the load balancer is actually sensitive to this B being available or not available, at least in modern infrastructures, so that now A will talk to this B or this B if this B is gone. So now we've effectively introduced an abstraction here, that abstraction abstracts from the identity, concrete identity of the backend service that you're talking to, and with that you're reducing the coupling on a particular instance. Now you have to pay a price for this. The price you pay is coupling at the back end. Here on B, you have, if you are hitting this guy first and then you're hitting this guy, based on that load balancer, or even a failover mechanism, as you will find it in failover clustering, you will still expect that you get the same or very similar results, the same kind of data, that it's consistent to some degree. So you're going to pay with those instances of the same service coupling to the same storage. Or, alternatively, you're going to have a model where each of these systems going to has the same projection of a store. So these stores are similar, and then they're going to be kept in sync by replication, and that's a model called eventual consistency. So when you're using the abstraction up front, if you're kind of doing this for the purpose of availability, so we're talking here about a failover cluster model, load balancing kind of accomplishes the same thing. you still have something you pay for this, is in this kind of a shared disk, worst case, or eventual consistency, best case with a lot of asterisks on it. You have to pay for this. I'm not going to talk about coupling on the data side because that's a whole different talk. But let's go and continue on the messaging path. So I'm going to go and take this away completely and redraw it. Let's talk about, well, scalability is kind of obvious. We have many, many, many A's, and then they hit one B, and that's unhappy. Second is timeliness. Timeliness in two ways. First of all, A may be dependent on how busy B is, and if B is enormously busy and the backend resource is enormously busy, it will take its sweet time to go and do things. And depending on what answer A expects, waiting might actually not be worth it. If all you want is effectively a receipt that says, yes, I have it, well, then you should not actually be waiting on B to go and take your message. What you should do instead is you should put something else in the middle, and that is some infrastructure, a queue. Putting a queue in the middle means that you can go and send the data into the queue, which might even be local to you, which replicates into a queue that B can look at, and then B can go and pick it up, which now means that you have temporally decoupled A and B. B can even be down and completely be unavailable, and A can still get rid of the messages, can go and send its data out into that queue. And it can be sure that the data can be delivered because the queue is a reliable infrastructure. So that's how you decouple now the lifetimes of A and B, and you also decouple A from B being responsive within a period of time. And then there's a number of mechanisms, which we're not going to go and discuss today, which allow A to get feedback about the outcome of that the transaction you have initiated here. So again, I'm not going to talk about that here because I want to get to the coupling with data. For A and B to have this conversation, it's not only important how they are having that conversation, whether they're going to have that through a queue or whether they're going to have that directly, and whether that's abstracted or not. All trade-offs you make depending on the interaction patterns, and also the timeliness you need to have for that interaction. So there's all explicit decisions that you make in your architecture, but they also need to agree on what data is being exchanged, what the shape of the messages is, and what the shape of the data is that's contained in the messages. It's an agreement that needs to be made, and that's actually the biggest pain point around coupling that we commonly see, and it's something that effectively the history of web services, since that has been started in the mid-90s, is mostly about thinking about how to exchange that data in a formal way. And it turns out that over-formalization hinders more than it helps. So I'm going to spend the rest of the time today talking about messages and data and how to express those, and kind of the slippery slope we've been on in going from effectively a data declaration, which is a list of fields, towards coupling on type, which we actually started out to avoid in the first place. So, quick history lesson to this. We kind of started in a world with web services where we had Corba and COM and DCRPC and a number of other systems. What they did is most of them were all creating a notion of wire contract, wire agreement, which was largely loosely coupled. Now, a lot of people in the distributed system space are now going to throw up a little in their mouth. They were loosely coupled in a way that they were not dependent on a particular language, and they were not dependent on a particular type system other than their own. So Corba had a type system, COM had a type system, DCRPC as a precursor to COM had a type system, and you could go and you can still do that, go and write a Visual Basic program and consume data from that Visual Basic program in C++ or in C# very easily, because there's a common type system, a common notion of type that is shared between all those different languages and runtime environments via the common type system that's there. So based on that history and that experience, Corba had one, and Com had one. It was fairly easy as XML came around to kind of standardize on the common type system on XML, which then happened, and that was kind of the web services, XML web services movement. So we all started to standardize on the XML type system, because that was a success recipe for both Corba and Com. So what we did is we took the simple types, and we also took, well, because they were there, the complex types of XML, and made our messages look like that. So you had a message, and you start with some kind of tag, and you say, I'm going to send you a lead from a CRM system. So I'm going to send you a lead, and inside that lead I'm going to have a first name, and I'm going to have a last name, and then I'm going to have a title, and then I'm going to have a mailing address, and I'm going to wipe this away because I need to go a little bit further in here. And I'll only have a mailing address because people, if I have a lead, I may actually have a business address, and I may have addresses in multiple countries. I have, for instance, on my business card, I have a mailing address in the US, I have one in Germany, and I have mailing addresses, and then I have an address here, and then there's a city, and a street, blah, 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 and that's my address. And then I have another address. So you kind of know where that goes. So we effectively took the XML type model and said, all right, this is how we can express messages because it's beautiful. We have a common parsing infrastructure. We don't need to worry about parsing those things out. We have a common wire format. It's fine. Bandwidth is ever increasing. We don't need to worry about bandwidth, which was not very wise in hindsight. And so we're going to use that. It's all fine. Even though there was a little verbose, because of course each opening tag kind of needs to have the end tag. So that kind of gets a little long. So far, so good. So we had a common type system. Next thing is, now we went and took these kinds of simple messages and wanted to formalize them. So you need to have if you exchange those things, you kind of need to have a description of how that happens. Possibly an example of this document is, just as I'm writing it down, would have helped. If I had written this document down, instead of this form, in XML schema, it would be much harder for you to actually follow that. XML schema is very interesting in that it is able to actually go and capture this flow, but it's actually built for some completely different purpose. XML schema, and people who are in the XML or were in the XML schema working group might dispute that, but I would argue that XML schema is actually built to express the following: HTML head /head with meta tags and script tags in here, body, with any kind of tag that you like, maybe table having a T head, having a T body, inside the T body a row, inside the row a column, inside the head of the table a table header. So effectively defining a syntax for a language, and that language being HTML, or that language being whatever other XML-based dialect or whatever other XML-based language, description language, markup you would want. That's a markup language. It's a framework for free-form expression, effectively, of a language that's driving a browser. That's not what this is. Right? This is very different. This is something that's delivered into an application that kind of expects a certain set of data and deals with it. This is something that is delivered into a browser which actually doesn't have a preconceived notion of what it is. This is a program, if you will. This is data. Program, data. XML schema is really good at defining declarant syntax for program. XML schema is therefore completely overpowered to go and write schema for data. I would personally argue with 20/20 hindsight. So it's not that I'm making the claim that I knew this all along, certainly not, but I think that XML schema was actually the wrong choice in that it's overly complex. And then it did something fairly terrible. So we start with this, and now we start building a schema out of this. What this results in here is, so I'm going to take this as a document. I'm going to mark this up, and I'm going to say, there's a lead, and the lead has a list of mailing addresses and an address. Now this did the following. This resulted in a class lead and a class address. And once you do this, once you kind of describe this as schema, once you're starting to build complex types, you're halfway down the slippery slope of taking a message, taking pure passing of data between A and B, where A is written in some language and B is written in some other language, and starting to kind of attach semantics, class semantics, OO semantics to it. And once you're there, it's very easy to get trapped into abstraction. So now, here, we take this message and we say, all right, so that's a lead that we submit, and it has some mailing addresses. Once you make this a class, once you make it a thing, once you give it a name as a type, you're now saying, whoa, wait, so that's not a lead, really. The lead is a person. And the address here, well, that's probably a base class for a street address and a PO box address, or address, I should probably say. So we get people going on these very slippery slopes towards constraints and extensions of these classes, because now that we've mapped this data, the flat data, onto complex types, and with that into language constructs by ways of serialization, you're automatically kind of landing in that world of OO. And now, because you're doing that, we now need to go and take these constructs and map them back into that world. And now comes XML schema back, because XML schema is kind of has strange ways of how expressing things, because it's made for markup. So it does things like this. You have a complex type. So complex type. And that thing has a name, lead, which is it's a constraint of person. I'm going to go put this in here. So and that has an element. The name of that is title. I'm going to take the first name and last name to be inherited from the other type. And now I'll need, if I close this here, oh sorry, I forgot sequence. So this is a sequence, which means all these the elements that I have need to go and show up in a particular order. So there's a sequence here, and I have element name, title, and so I have, and this is an extension of, or actually constraint of, the person complex type that I didn't put in here. So now the way you need to go and send the data is first name, last name, title in that exact order. If you don't, you're violating the XML schema rules. Now practically nobody follows those. The serializers, at least in the .cf world, the serializers are actually very tolerant about the order that the elements come into. So the serialization infrastructure, the implementation of the infrastructure is actually ignoring the rules of XSD that are implying sequence. Because if you don't make it a sequence, the thing you can't do is to put an extension here, a declaration that's called any. And any means if you are sending more data into a service implementing this complex type, that is okay. So you make this future-proof by allowing in this version of the schema extra elements to be sent. Unless, if you don't do that, if you don't add an any element here, well then extra data, if you ever do schema validation on that document, will be rejected and will cause an error. So it's effectively the anti-pattern for loose coupling to do schema validation without having these extra, I want to have except extra data, because it certainly is decidedly not future-proof, because you can't know all the data you will ever receive, right? Go back to the example of the lead here. You certainly want to have a Twitter handle in here these days, right? Would you have wanted that 8 years ago? Probably not. Should you allow the Twitter handle to be null flow and also save the extra field? Probably. So it's kind of dangerous to code up a schema that is non-extensible. So they need to be extensible, and when they're extensible, because of the strange rules of complex type, in XSD, they need to be a sequence, which means now you get to pick between the rules you want to break. You want to break the rule of any extension, or do you want to break the rules of fixed sequence? Because schema per se doesn't give you any alternatives. So now we're kind of with that mapping into XSD, with that mapping to classes, we kind of step the first step onto a fairly slippery slope. And then the following thing happened. So as the Windows Communication Foundation came along, and it's kind of the biggest influence in terms of services, certainly in the Microsoft developer space, the idea to do things was the following. We have a service A, we have a service B, and A takes a dependency on B. B offers some data in following a particular contract. So B has a declaration of the data that it wants to offer. So that's kind of the ground, the basis for a contract. So it writes down the message schema, it writes down the data schema, and then the message schema is referencing this. The data schema is kind of a basic notion, just as I had this, so I'm going to call this A, B, C, D, E instead of first name, last name. So you have this message schema, and now you're going to take this message schema and map this onto a type. So class, or a data schema. So class data, and the class data has fields, and I'm going to omit the type here, C, D, E, as a, just to keep things short. And then we would go and declare all those data members with a data member attribute. In .cf, this is called a data contract. And you'll notice that it's not XML schema. That intentionally was abstracted from XML schema, not to expose the application to all the intricacies and all the complexity of XML schema, but basically just have a simple model where you have this An abstract model of contract, of data, would map that onto a simple structure where you would have data members kind of sitting in that way. That was the original intent behind this, that you would go and have this simple class and would label it, and that would cause your abstract data model to be projected onto a class that you can then use for serialization. And you can go and use that to serialize into XML, or you could also use that to serialize into JSON, and the serialization infrastructure that you can get with the stock.NET framework actually allows for both. So it's not XML, not tied to XML. What then was the intent and first practice, and it actually also is manifests in the tooling of WCF, is that with B, with that service where you have that class sitting, you have a metadata endpoint. And that metadata endpoint is consuming that class and is projecting out schema. It's projecting out a formal description of this class in an abstract notion, an abstract way that is consumable by other clients. So it has a metadata package, and the metadata package consists of WSDL and schema and policy. And there's a client A, and if you build that client A, well, you use the Visual Studio tooling or you use service util, so the intent, to go and look at this and spit out a class, assuming we're .NET, data, that has exactly the same field. Now the interesting thing here is that class here is completely distinct, it's separate code, it's generated out of this metadata. There's no separation, there's complete separation between those two pieces, between A and B. The only thing they have in common is a common view of that metadata document. If I now go and add a field here, this will still work. If I add a field here and I get that field and I return that field here, this will be simply ignored because that's how the serializer works. If I go and were to send this element, a structure like this over the wire, it will be the extra field. What I would have would actually also be ignored here, and you simply wouldn't find it. Sorry. Again, so if I wouldn't send the field, I have that wrong. So you have the field F here, and that's only known to B. And now A sends a message and includes only data for A, B, C, D, E. Then F will go and replace the missing value with whatever the default is here. So there's a built-in loose coupling model, and there's a complete distinction of type. This will also work if you fire this up in NetBeans and use the JAX-WS stack, the Metro stack from Oracle Sun, and go against that endpoint, because that's optimized for that model. So you don't share anything. So what's the intent? Practically, that's how it goes. What happened is that most people actually left this part out, because it's .NET to .NET, mostly, so we can do something else, people said, generally. And I have to say I've been guilty of this, so I'm not going to try to be a revisionist and say I knew this all the time. So you have this beautiful code that you wrote, and what you'll now do, step one, is you have an assembly that is underneath B, and you have an assembly that's underneath A, and what you'll do is, in your build project, this is the lesser sin, you go and include a reference to that file. Now if you do that, you're no longer sharing metadata, which means a Java client can play. So you've now coupled yourself to C# effectively. If you're just building pure .NET apps, that may not be a huge issue for you, but you're now coupling on that class file, but you're still coupling on the file. Even if the namespace declaration is the same, what you're doing here is you're still creating two copies. So what I said earlier, if you now extend the data contract with F, right, and recompile B and deploy it, the behavior implemented in the data contract model and the serializers and how they work is still preserved. A will go in and not send that extra field, and it will be replaced with a reasonable default. And B, if it returns the data, will send an extra field which is going to be ignored by A. And there's a way to go and implement extensible data object for which you have to implement an extra property. And if you do that, you get an anonymous data container, if you will, that even allows round tripping through A if A gets extra data and wants to go and edit some data and send that back. That little container will actually contain the extra data that A doesn't have an idea about, but B already knows. So that's step one. Step two that people took was not to make that a reference, but instead, that's the second step on this. I mean, you're already sliding here pretty hard on that slippery slope. In putting this into an assembly, and we're going to call this contracts.dll. So now you have an assembly, and that assembly is something you reference straight from. Sorry, I'm going to do this right. It's an assembly that you referenced straight from A and B. As long as you independently deploy them, as long as A and B get their own copy, you're effectively independent here by allowing to have 1.8 deployed here and 1.7 deployed here. The effect is basically the same as compiling that into your application. That's not so dangerous yet. When it gets really problematic, and where you're now starting to tie A and B together at the hip and effectively throw away their independence as independent services and turn them into one service, is if you start doing things like this. If you send a message across the wire and you're doing things like polymorphic arrays, and you're trying to tell the other side what kind of type there is, and you do things like this. This is an A, version 2.0, right, from the assembly contract DLL. So if you end up on this slippery slope down in the valley where you're taking a fully qualified .NET type reference and send that across the wire, you no longer build two services, you're now building one service. Because you've now finished the path to the dark side of tight coupling, because now you're actually dependent from both sides to a particular version of a type. So we went from a loose notion of data that's being mapped to a type for the purposes of integrating that into the .NET framework, to sharing of code, to sharing of compiled code, to sharing of an exact assembly reference. And that's a trend that that I've seen in a number of also community frameworks, that you're actually getting these kinds of type references on the wire. And that's kind of the worst kind of coupling you can have, because this now immediately impacts your ability to go and service and scale your system. What you can't do anymore with that kind of a model, where you now have a common, where you now are sharing type information across the wire, is you're now requiring, if A gets upgraded, and A does that, so A sends a reference over to B, to ask B to load a particular type, B must have been upgraded to understand that, otherwise it won't understand that message. So you are effectively requiring a simultaneous deployment of that particular type to all parties, which means you are making it really difficult to create no downtime upgrades, because ultimately, if you want to keep a system running, no downtime upgrades for us means the system stays up within SLA as you roll an upgrade. If I had a version dependency across the wire as pieces of the system talk to each other in that fashion, well, I would have to go and do a full upgrade of the system by first deploying the assemblies and then go and turn on the next functionality of the system in the next step, which means ultimately that would make my deployment model much more complicated and really much harder to test. It also completely precludes that you can talk with a non.NET client to a system like this, because that kind of a reference doesn't make sense to anybody else. So that's kind of the extreme end of the slippery slope of type coupling. So that's a dark story. What should you do? Well, I think that here, the basic notion that I just established here, that simple list of fields is actually not a bad idea. Where you have a contract, and that contract is expressed as, here's the data I want to send around. And the nice thing about a list like this, and when I say list, I mean a document, a web page that says, here's a field, here's the type, and here's what that all means. And I would recommend that you go to, that you for instance look at the documentation that we have for properties in our APIs, or if you want to have a different example, go to the developer pages for Twitter and look at their APIs, or the developer pages for Facebook and look at their APIs. And you will see numerous data structures, also large data structures, and they're described in this way, right? You have properties, what is the type, what are they for? So you have a documentation that actually writes that down. And they will tell you, here's an example of how that looks, how it goes across the wire. It turns out that functions, that works. And we also do that in a very practical fashion for messaging with Service Bus, where our messages can go and carry any kind of content. And meanwhile, to be fair, I actually prefer JSON, because JSON has the exact set of primitives, type primitives, that you need to declare the content of a message, which are you have a map. The map is a dictionary with unique keys, where the content can be a simple type, string, or where the content may be a list of things, where the thing might be, again, a simple type, or it might be another array, or it might be a map. A construct like this. Or you may have as the content, well, a map outright. So you have a map, dictionary. That dictionary can contain as values simple types, or arrays, or maps, and it's kind of it's self-referential. So the map can again contain what this map contains, etc. So if you have a type system like this, if you have a declaration like this, if you declare your things, describe your things like this, that's sufficient. That model, that schema that you build in documentation, maps perfectly straight into JSON, because JSON does exactly that. JSON has a has a unnamed dictionary that it starts with, that's the outer bracket. It doesn't carry any notion, any identifier of type, that's fine. And then it contains another map, or it contains arrays. So the data model of JSON is actually sufficient. If you take a look at AMQP, the Advanced Message Queuing Protocol 1.0, and that type system is very similar. It also has maps and arrays and simple types. So and then actually, if you take a look at an XML document per se, an XML document is very similar, with the only key difference being that it allows duplication in its element names. So it doesn't enforce the uniqueness in the map. So you can go and take a look, you can look at the child elements of another element as a map, because the element name kind of serves the identifier, but XML allows dupes in that, and JSON and the JSON processing model typically doesn't. So, but for structured data, JSON is actually a very fine model. So what I would recommend, at least to consider, is to actually go with that simple thing and have documentation. Actually think about the structures, think about the wire, think about the things you want to go and exchange, and then leverage that simple model and map that into the natural mapping. The most straight mapping is into JSON, but you can also as a straight way go and map that into XML. Can map that into AMQP, and you can map that into all other kinds of things. The route through sharing type, sharing runtime bound type is something that I certainly advise against, because what we see is certainly in Windows Azure, a huge amount of variety of runtimes and platforms, where I have inside of Windows Azure a lot of workloads that run on Node and on .NET and on PHP and on Java, and we have the same kind of variety on the client platforms where we have Windows and Windows using JavaScript, and Windows using C# and Windows using C++. We have Objective-C on iOS. We have certainly Mono that we see on iOS, and also Android, which is a wonderful thing. And we have Java on Android. And we have embedded devices which are using C. So there's effectively any language that you can come across, any runtime you can come across, is something that is common. And if you're constraining yourself in the message design to a particular runtime, into a particular representation system like XML, you're actually increasing coupling to that decision. So loose coupling ultimately in messaging means to take the most open, most broad stance that you can have, and locking yourself into a particular schema, particular schema formalization is not a good path to success. So you should be, my personal stance at this point is that it's probably better to have a documentation page that intelligent human beings, programmers, can look at and can turn that with examples into a wire format, than having a machine-readable thing that can then be evaluated. I think that might be a better way to get to looser coupling than trying to get the super formal, overly formalized route. So that's probably a bit of escalated into a bit of a rant against XML schema, and trying to be an advocate for openness, advocate for cross-platform interoperability. What XML tried to provide, where we've seen people vote with their feet effectively for alternatives to go JSON and also on the messaging side to go AMQP, so that diversity in messaging is something that people value, and for that we need to have common agreement around the contents, the data we're going to send around. And I think the best way to go about that is to be less formal about the agreement, and to write things down and then be keenly aware of what's going to go on the wire, and not simply trust some magic dust, pixie dust that abstracts all that away from you. So I don't really have a good way of ending this, not a happy message that says, go and do it like this, but I'm simply want to raise everybody's attention to the point that being explicit and being aware of what's going on the wire, and to be lenient in terms of what you accept, right, and liberal in what you accept, and probably take some extra data and store that in an extra part of your database, even if you can't interpret it, is probably a better way than constraining things completely down to nothing, because there's things that that are going to happen to systems that you build today, which you simply can't anticipate. For instance, not including a Twitter handle 7 years ago, and those are things that you can't build into the protocol today, and they will show up over time, and you need to deal with that change over time. Thank you very much for your attention. I know this was very long, so thank you for everybody who's been sticking with me through all this. See you next time.